All right, this is the first problem in 7.6. And what I've done is I've also added in a picture of the die, the different outcomes you can get from a pair of dice, because that's what we're dealing with here. But let's just remember, what is expected value? Expected value, essentially what we do is we take each outcome and we multiply that outcome times the probability of that outcome. Okay, so it's the prob of, sorry, I wrote a little sloppy there, prob of that outcome. And then we take those multiplications, those products, and then we add this up for all outcomes. So you take each outcome times the probability of getting that outcome. So if we roll the die, we get the sum shown on the dice. Okay. So this particular outcome right here, you're going to get $2 because you're showing a 2. Okay. Let's try a different color here. Either of these particular outcomes is adding up to 3, so you would get $3 from those. Okay, we can keep going along. I guess we'll just kind of alternate colors a little bit. These guys would give you $4, etc. Okay, and we could keep going. Let's just do I won't show you all of them. You can kind of list them yourself. Let's see. This guy would be, this diagonal right here, all of these guys would be a $7 outcome, as an example, because they all add up to 7 in different ways. Okay, I'll do one more for you. You can do the rest. This guy here would be, what's that, 10? That's $10. Right, because those all add up to 10. I guess, all right, I'll do one more, okay, just because this is fun. Okay, that's going to be $12. Okay, that's the biggest payoff. Okay, and you can do the rest. Actually, should we just finish it up? We're almost done. I might as well finish it up. I know. I'm silly. This would be $5, right? These would be $6. Let's see. This would be $11. I got 2 more, right? Just kind of zip through these. This guy would be $8. All of these outcomes would all be $8 outcomes because they all add up to 8 on the dice. And then we got a $9 outcome right here. All right, $9. Okay, so those are the different outcomes. So now we want to, now these are actually, when we say outcome, this is the outcome of the dice itself, but you're not just winning that amount of money. You have to pay in $9. Okay, so when we list the actual, when we make it, we're going to make a little table, outcome times probability, outcome, and then we'll make a table for probability, or column, I'm sorry, for probability, and then we'll multiply them. So it's going to be the outcome times the probability in my third column, and then that's the column we're going to add up. Okay, so we have an outcome column, a probability column, and then a column for the multiplication of the two. Okay, that's supposed to be parentheses. Now, my first outcome is 2 as my winnings minus a pay-in of 9, because you have to pay 9, is actually negative $7. So if you roll snake eyes, so-called snake eyes, 1 and 1, you're going to win $2 in the game, but you paid $9 to play the game. So you're actually losing 7. Now, what's the probability of that? Remember, probability is the number of outcomes that give you the event divided by the number of outcomes that give you any event. So how many outcomes give you the event of getting a 2? The answer is there's one outcome, right? There's one outcome, rolling a 1 and a 1. But there's 36 outcomes total. So your probability is 1 out of 36. So if I multiply, I'm going to have negative 7 over 1 times 1 over 36 is negative 7 over 36. Okay? So this is the probability, the outcome times the probability of the outcome for that first possible outcome. Let's do the next one. I can win $3, but I'm paying in $9, so that's a total payout of negative $6, a loss of $6. How probable is that? What's the probability? Answer, 2 outcomes, a 2 followed by a 1, or roll a 1 followed by a 2. 2 outcomes out of 36. Now, I could reduce that to 1 over 18, but I'm going to avoid reducing because I want to keep a common denominator. I want to keep my denominator to all be 36s, so it's easier to add stuff up later. So I'm going to multiply the outcome, which is negative $6. I can write that as negative 6 over 1 times 2/36 gives me negative 12 over 36. Okay? Let's see. Let's just kind of skip along a little bit. You can kind of fill in the next ones. I'll do like a couple more. Let's try maybe that $8 payoff. How about the $8 payoff? Okay? So the $8 payoff minus 9. So now I'm doing this column, or this diagonal, would be a total payoff of negative $1. I'm skipping, there's going to be what? There's a 4 minus 9, a 5 minus 9, whoops, a 6 minus 9, a 7 minus 9. I'll just do some of these for you. You can fill in the rest. Now, what's the probability of getting an $8 payoff? You've got 1, 2, 3, 4, 5 ways that can happen. So the probability is 5 out of 36. And so if I multiply, I'm going to have negative 1 times 5 out of 36 gives me negative 5/36. Right? Let's try another one. I'll try like, I don't know, let's try the $11 payoff. Let's try this guy. How could I get that $11 payoff? Okay, well, I'm going to get 11 from the dice game, but I'm going to be paying in $9. So that's just a $2 payoff, positive $2 total, or total $2 outcome. And so the probability of that is how much? There's 2 ways to have that happen. 2 out of 36 is my probability. So if I multiply, I'm going to have 2 over 1 times 2 over 36 gives me 4 over 36. And again, I can reduce that, but I'm going to avoid reducing, so I have common denominator. And of course, your last one is going to be the $12 minus 9 would give you a $3 payoff. That's going to be when you multiply. Well, the probability is 1 out of 36 because there's only one outcome for that. And so you're going to have 3 over 1 times 1 over 36 gives you 3/36 when you multiply. And of course, I skipped a few. I'm leaving the rest for you guys to fill in. Okay? And then you're going to take this column right here, these numbers right here, and add them up. These are the results of the outcome times the probability. We're just going to add those up. And remember, the over 36 part's not going to change. So when you add those up, the denominator is going to be 36. So the numerator is going to be, you just start adding, like negative 7 plus negative 12 is negative 19, and you just keep adding. The 36 is not going to change because you have a common denominator. All right? So when you get your final result, at that point, once you have your final result, at that point you can reduce to a decimal if you like, okay? And see what the expected value is, okay? Pretty cool. Right? It's a little complicated because of the dice situation, but with the diagram, it's not that bad. Okay? All right. Not too bad. Maybe just one bad? See? Not too bad. Just one bad. How's that joke? It's like a 5 bad joke, right? All right. So let's go on to problem 2. All right. So for problem number 2, we don't need a fancy diagram in this one because we're not playing like a well-known game here. They're describing the game to us. So there are different outcomes, right? You can lose. You can win 40, okay? You can win 25. So there's only 3 outcomes, all right? So if we make a table, it's going to be a simple table. So we're going to have outcome, probability, and then outcome times probability. Same as before, because outcome times probability, that's the expected value. You just add that up across all the outcomes. So my first outcome would be that you can lose. Okay, which means you win $0, you earn $0, but you're paying in $5 to play the game, so that's a total payout of negative $5. Okay, the probability of that we're told is 7 out of 10, or 0.7. Okay, so if I multiply that, it's going to be, so I'm going to have negative 5 over 1 times 7 out of 10 is what? Negative 35/10. Okay. Now, if you divide that, it's just going to be negative 3.5. Okay. Now, the next outcome is you can win $40. So your payout is 40, but you're paying in or losing $5 to play the game. So your total payout is actually $35, not 40. What's the likelihood of that happening? 1 out of 10. Okay. How about then? And then I'll let you do the rest. Okay, you kind of, you can work this out. And then my next possibility is you can win $25, but of course you're paying $5 to play the game, and so you're only winning 20. What's the probability? 2 out of 10. Okay, notice that this adds up to 10 out of 10, which is 100%. You have to make sure your probabilities add up to 100%, otherwise you're missing one of the outcomes. Okay, 7 and 1 is 8, plus 2 is 10. 10 out of 10, your probabilities are adding up to 1, which they should. Okay, if they don't, then something's wrong. Okay, and then of course when I multiply the 20 times the 2/10, I'm going to get some numbers over here, and this is the column that I'm going to add up, and that total is going to be my expected value for the game. Okay, and again, you can add that up as fractions, or you can add it up as decimals, either way. Okay, and if it turns out positive, it means you win on average. If it turns out negative, it means you lose money on average by playing the game. All right. Usually, if it's a professional game, like run by a casino or something, usually the expected value on the player's perspective is going to be negative, which means on average players lose money, and that's why the casino can afford to run the game, right? Because you lose a little bit each time you play on average. Okay? All right. But anyway, so let's go on to problem 3. Okay, so this is our problem number 3. And so what are the different outcomes? What are the probabilities of getting that outcome? And then what happens when you multiply? Okay, so one outcome would be that someone makes a claim for $5,000. Now, this is from the perspective of the insurance company. So if we pay out $5,000, that means that's a loss to us. That's negative $5,000 for us. So you have a negative $5,000 payout, but you're collecting $1,300 from that person to have the policy. Okay, so what are we going to have? Negative, what's that going to be? About $3,700? Right, because you're paying out $5,000, but you receive $1,300. So that means that in essence, on balance, you're paying out $3,700 to that person. Now, what's the probability of that happening? 0.11 in this case. Okay, so if I multiply, it's going to be negative $3,700 times 0.11, whatever that works out to be. Okay? Now, what's the next outcome? Next outcome is total destroyed, right? That contents are totally destroyed. You're going to have to pay out $150,000. That's a payout, which means you're losing that money if you're the insurance company. But of course, you're collecting $1,300 from that person, right? So what's that payout? That's going to be negative $148,700, I guess, right? $148,700. That'd be $149. Yep. Okay. So that's how much you're totally paying out to that person. You're paying them $150,000, but you took in $1,300 from them. Okay. What's the probability of that happening? 0.0045. Okay. And so what's the outcome times probability? Again, negative 148,700 times 0.0045. Now, what's the third? Now, notice the probabilities don't add to 100%. That means I'm missing something. Okay, what am I missing? I'm missing the fact that for a lot of people, you're not going to have to pay them anything. There's no claim made. A lot of people don't make a claim. So you're paying 0 to them, but you're collecting $1,300 from them. So that's a payout of positive $1,300 to you. In other words, you're collecting $1,300. What's the probability of that? It's the remaining probability. 1 take away whatever we've already accounted for, because they have to add up to 1. The probabilities have to add up to 1, which is 100%. So 1 take away the 0.11 plus the 0.0045. So add up the 0.11 and the 0.0045, add that up, subtract that from 1, and that result is the probability that people will not make a claim. And then, of course, we're going to just multiply the outcome times the probability. All right, and then we add those up. Add them up. Just boom, boom, boom. Add those results, and that will be your expected value. Okay, and hopefully it's positive. If it's positive, that means the company makes money on average. If not, that means they're not charging enough for the policy. Okay? Good? All right, let's go on. Problem 4. Okay, so this is number 4 here. And so, whoops, what's going on there? Hang on a second. Okay, so we're in problem number 4 here. So number 4 again involves rolling a pair of dice. And the question is, our outcomes, if our outcome is divisible by 3, we pay out $30. Okay, if it's not divisible by 3, then the friend pays us money. So which ones are divisible by 3? Well, if the total is 3, then it's divisible by 3. These guys, a 2 and a 1 or a 1 and a 2, give you a total of 3. That's divisible by 3. These guys give you totals of 4, total of 5. Again, don't mistake this for a total. These numbers are not the totals. This is just what you get on the second die. This is what you get on the first die. Okay, these numbers. The total, you have to add them up. So these are 5s. These are 6s. 6s are divisible by 3, right? These are 9s. Those are divisible by 3, right? And then 12 is divisible by 3. How many outcomes is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes out of 36. All right, so let's start making our table. So we're going to have, typically we make a table that says, outcome, then the probability of getting that outcome, and then the outcome times the probability. Sorry, my pen is a little slow here. Okay, so, but in a case like this, I'm also going to add an extra column called description of the outcome, just to kind of help us organize the data a little bit. So my first description is an outcome that is divisible by 3. So if you get an outcome, if you get a total that's divisible by 3, what's the actual payout? By the outcome, we mean the actual payoff. How much do we get? Well, if it's divisible by 3, we pay our friend $30, which means we're losing 30. So to us, that's negative. Okay, now what's the probability of that happening? We just showed there's 12 outcomes out of 36 that are divisible by 3. So that means we'd be paying out, the probability of this having to pay this money out is going to be 12 out of 36, or you can reduce that to 1 out of 3, right? Because you can reduce by 12s. So if I multiply, I'm going to have the outcome times the probability, okay? Now, the next possible result would be not divisible by 3. How much do we either pay out or earn? Well, we don't know. That's what we're trying to figure out. If the total is not divisible by 3, how much should he pay us? If it's not divisible by 3, we don't know. So but it's money that's coming in, so it's positive. So I'll just call it X dollars because we're receiving it, so it's positive. Now, I do know the probability. If 12 outcomes are divisible by 3, all the other ones are not. So how many remaining outcomes are there? Obviously 24 of them. And if we reduce that, we get 2/3. And notice if I add up these probabilities, I get 1/3 plus 2/3 is 3/3, or 1, which means I've accounted for everything. Okay, your probabilities always have to add up to 1, otherwise you don't have a complete problem. And what is the outcome times the probability? Well, it's going to be X is the outcome times 2/3. Now, if I add these up, I'm going to add up this column. That's going to be my expected value for the game. Notice the expected value is going to involve x's. We don't have a fixed value. We don't have an actual number. We have an expression with x's because we haven't figured out how much that they have to pay us yet. But the idea is we want a fair game. A fair game is when you get $0 in total expected value. Meaning you don't expect to lose money, you don't expect to win money on average. That's what a fair game is. So we're going to take that expected value and we're going to set it equal to 0 and then solve for x. We're going to find the x value, the value of x, that makes the total expected value end up 0, which means we don't lose and we don't gain on average. Okay? And that's how to finish this one up. All right, cool. Let's go on to number 5.